I have you loud and clear.
Hello. Welcome. Science.
And that is to say,
physics,
medicine,
nature,
or
space, time,
the brain,
life, the universe.
Hello, welcome to The Naked Scientist. This is the show where we take you to the cutting edge of science, technology and medicine. My name's Chris Smith, and this week we're solving the science questions that you've been sending us. On the way, how do glowworms glow, and can they do that indefinitely? Why don't birds fall out of trees when they nod off? And space tourism. When can I book my ticket into orbit?
The Naked Scientist podcast is powered by ukfast.co.uk.
Now, with us today on The Naked Scientist are a panel of experts who are answering your science questions. Richard Hollingham is an award-winning space and science journalist. He also makes the Space Boffins podcast. It's been going a while now. It must be 8 years, 9 years?
It is 8 years. More than 8 years, yeah. I know. We were one of the after your podcast, of course, we were one of the early podcasts. And now everyone's doing it.
Yeah, and going strong, though.
It is. It's still going very strong. Yeah.
And what have you brought for us today? What's got you fired up in the space realm?
Oh, look, I brought some show and tell. It's in a plastic bag, as you can hear. This is from 1954, The Boys' Book of Space. Only for boys.
Where did you get that?
Patrick Moore.
Yes.
Actually bought it from a charity shop in Norwich. I mean, it goes through all the science, everything we know about the moon and Mars. And actually, what's interesting, there's a section at the end which it's got some beautiful pictures of retro rockets. So this is 1954. So there were rockets. So we had the V2 rocket, we had other rockets, but no one had put anything into orbit yet. So the first satellite was 1957.
Well, I love looking at text like that to see what people's predictions were, because Star Trek, if you look at Star Trek, I mean, it wasn't Patrick Moore's book, obviously, but it made interesting predictions about where we would be with tech by X years, and much of it's come to pass. So what does Patrick Moore say? Yeah,
well, that's really interesting. So he says the first true space flight will take place sometime between 1980 and 1990. So way off then. So we had the first satellite 57, first man in space 1961, man on the moon 1969. But some things are pretty much spot on, and the space station will be fully planned by 1995, and its construction will start between 2000 and 2020. So, we have now the International Space Station. Right now, there are 6 people on the space station. It's been continuously occupied since the year 2000. So actually, space station-wise, pretty much spot on. First lunar voyage by 2020. Well, we've had that 69, but we're going back by 2024, and first expedition to Mars will set off around 2050. He is probably right.
He's a visionary.
He is, yeah, and he's probably still right. Boys' Book of Space.
And talking of being visionary, sitting next to Richard, Kes Latham is a vision specialist. She's at Anglia Ruskin University, so horrible pun, but what's caught your eye?
Thank you very much. What I have brought with me to follow on from the space theme, I've brought some low vision aids, and the first one I've brought is actually a telescope. But this is not the sort of telescope that you would use for looking at the stars. Well, you could, but it's a low vision aid to help somebody who doesn't have terribly good vision to magnify things in the distance.
If I may describe it, looks like a pair of glasses wearing a pair of glasses.
It does look exactly like that. So we've got a spectacle frame, it's got a lens at the back, and then actually what all a telescope is 2 lenses separated by a gap of air. And that's exactly what we've got here. So we've got a rearmost lens and then a gap of air and 2 lenses sticking off up at the front, a bit like sort of bug eyes. And we can adjust the position of the gap between those 2 lenses. And that will give you a magnified view of something in the distance, be it stars or be it the television.
So who would benefit from that chiefly, then?
Pretty much anybody who has got a loss of vision that means they can't see the things they would want to in the distance. We use a lot of techniques to magnify things to compensate for that. So the second thing I've brought is something that would magnify things for close work. And this is just a positive lens. It looks a bit like a paperweight, a sort of a slice out of a paperweight with a battery pack on the back. So the idea is that it's a curved lens, it's a positive lens which is going to create a magnified image. We've also got a nice light that shines into it. And once the light is on, it bounces around inside the lens so that we really brighten up the image that we've got there. And we also get some magnification out of it. So we make things bigger and brighter and a lot easier to see for somebody who's got vision loss.
Very informative. Thank you very much for that. Now, also here is Sophie Moles. She's also at Anglia Ruskin. She's been on the programme before. Now, you wouldn't show us what you've snuck into the studio. So everyone is eager to see what it is you've got.
I've kept it a secret until now. I've hidden it in my hat.
And I have this.
It looks like an enormous egg.
It is indeed. It is an enormous egg. Now, this is an egg of an emu. So I brought this back from when I was working in Australia. They farm them there, so it's all ethical. And it's been blown. So this is as it would be. But what's really interesting about it is the colour. Now, it's faded a bit. I used to have it in a stand, so you can see the original colour there. And it's a very dark, greeny black. Now, there are two pigments that are making that up. But the reason being, it's camouflage. So they have male parental care, and it allows the male to go away from the nest, and he can leave the eggs nicely camouflaged there. Ostriches have big white eggs because they're in very, very hot places. And being a white egg, it's obvious to predators, but it does reflect a lot of the heat. So that's stopping the eggs from getting scrambled. But what's really cool, and why I wanted to bring this in, because it's so different, is that a couple of years ago, dinosaur eggs were discovered with the same pigment in, which indicates that they had the same parental care mechanism, and it's probably male parental care there too. All from what we know about this.
I did read from researchers also in Australia a few years ago. They were looking at birds recognising their own unique speckle pattern on their eggs, being that they could then tell if, say, a cuckoo had come in and tried to sneak an egg into their nest, and they could tell that the wrong number of spots were on the eggs, for example. So that's another mechanism to avoid a different kind of predation, isn't it?
Yes, and cuckoos seem to be able to get past this, especially in the UK, where we've got different genetic lines of cuckoos that mimic the speckliness of different kinds of birds' eggs, for example, the reed warbler. The problem is your eggs are going to change a little bit over time. They're going to get bits of feces on them, bits of blood, and the speckling will change over time. So it's best not to imprint completely on them, just in case you make a mistake and chuck one of your own eggs out of the nest, because it looks a bit wrong now.
Sophie, thank you very much for that one. And sitting next to Sophie is Peter Cowley. He's a tech expert. He's also an angel investor and has invested in some 40 companies or so now, Peter.
Over 70.
Over 70?
Yeah,
okay.
Of which 50-something still alive.
Last time on the show, you brought in a jet engine the size of a small dice that one would play a board game with. Got lots of people who were intrigued by that. What have you got for us this time?
Yeah, this isn't the same at all. I was with a BBC film crew on Friday here in Cambridge, where we were filming how angel investors operate to try and disprove that Dragon's Den's the way that we live, which it certainly isn't. And we went to see a company that I'm a shareholder in and a director of, which has a device that detects bed bugs. So I have some bed bugs here. They are dead. They're surprisingly big, actually. They're about the size of very small ladybirds. And the device itself is here. The reason this was set up was a couple of guys here from Cambridge University who are in the 30s, actually. And one of them was brought up in Mumbai and had a big problem with bed bugs. So they've decided to go for pest detection. So not specifically bed bugs. They're also working on some forestry pests up in Scotland. And the device itself is different from the competition in that it's long battery life, very low power. So the bed bugs are attracted by a lure, which is made up of dead bed bugs at the moment. There will be some sort of chemical formula in time that crawl in there. There's a little camera, and it's the hardware in here has got to be as low power as possible. So it has a look and sort of thinks this might be a bed bug rather than a spider or anything else. And if it thinks it is, it sends it up to the cloud, where some machine learning...
Oh, it should be clear the image goes to the cloud,
yeah,
not
the bed bug, sorry. Yes.
That happens later, once the bed bug is dead, presumably. It does go heavenwards.
Exactly, wherever bed bugs go. And so that then goes up to the cloud, checks whether it is, and if it is, then it then emails the hotel, usually the hotel, it could be a hospital, it could be anywhere else, saying room 17 has a bed bug. And the point is, of course, is to get them earlier before they've multiplied, before they may then start biting the humans.
Does it kill the bed bug in the process?
It has some technology in there to do that, but that's not the point at the moment. The point is to make sure it is a bed bug and get in quick, and because there'll be other ones. You can't kill all of them, because the chance of there only being one and it catching it's not very high.
But they're horrible things. And I remember going to a conference in America, and this lady, it was really ironic. It was funny, but not funny for her, because she had turned up and she said, "I'm here to present my new book. It's all about bed bugs." And I saw her the next day and she had all these vicious red welts down her neck. And she said, "You wouldn't believe it. I've come to Chicago and I managed to get bed bugs in my hotel room." So she said, "I've not only written the book, I've now got not just the T-shirt, but I've also got the bites to go with." Peter, thank you. Now, with these shows, we have a Guess Who quiz that we run through the hour, and we give you a series of clues which will hopefully reveal to you what the mystery thing or animal is. Here is the first clue. This is what this thing sounds like. Don't worry, if you are confused, Richard's looking alarmed. If there's anybody who thinks they know what that is at this stage, do let us know. Otherwise, wait for the next clue and we'll hopefully put you out to your misery a bit later on in the programme. Now, Richard, let's start out with this question that's come from Diver John on the Naked Scientist forum. That's nakedscientist.com/forum. And he says,
if humans ever had to colonize Mars in a hurry, how would we choose the best people to do it?
What an interesting question. There's the how and there's the who chooses as well to that. Some scientists have done research on this, an anthropologist in particular, Cameron Smith at Portland State University, who I've met a couple of times. He reckons you need 2,000 people to successfully colonise. So presumably if you talk about in a hurry, right, we have to get off the Earth's being hit by an asteroid, let's get 2,000 people to Mars. So that's your starting point of around 2,000 people. And then it's the, well, who chooses? Okay, so let's say we've got a fair and balanced system of choosing. And I've been to several conferences on this, and I always figure that the people who go to these interstellar conferences and are really into this stuff are exactly the people you do not want to send to Mars. Let's take a room like this. Okay, so we've got a doctor, biologist, investor, an optometrist. So would you take, and me, and I'm a journalist, I'm also asthmatic, so I'm probably the last person you want to take. So I've gone.
So the journalist
Chris,
is out on the grounds that what? Because no one needs to know what happens on the journey?
Well, this is the interesting thing, actually, because if you look at this logically, you say, right, we need doctors, we need plumbers, we need electricians, we need engineers, we need those basics, and we need people to be fit and healthy, a nice cross-section. Actually, you probably also want, if you've only got 2,000 people, you want to take Earth with you. So you want artists, you probably want musicians, artists, maybe even journalists.
Lawrence Llewellyn-Bowen's on the set list then, for getting the space dome looking good.
You want a cross-section of society, you want a mix of people. You can get mired in the ethics of who you take, the sort of people you take.
Would you go, Peter?
Well, I came on this program about 2 years ago and had somebody sitting next to me who was on that list. I was trying to get on that list. Is it 100 or something people?
Yeah, so there have been various Mars projects. There was this project which is now gone out of business, which was you could sign up to go to Mars. All the people I met, and I can't talk about the person who was here. All the people I met who'd signed up, I thought you do not want to, not the right person to go.
No one wants to go to Mars. I don't mean as in they don't want to. I mean as in, to be honest, if they were sensible and they really were informed of the facts, they would not want to go to Mars, would they?
No, it's a horrible place. I think Elton John put it best. Mars ain't the place to raise the kids. It's a grim place. I suppose if we need to send 2,000 people off the planet to save humanity, then that becomes the question.
Would you go to Mars, Kez?
No. No, I would not be hurrying to get onto that list. I think I'd prefer to be on the B arc, as it were, in Douglas Adams' terms.
Yes, exactly. And that's a really interesting example, The Hitchhiker's Guide to the Galaxy. The B arc, the supposedly useless people, including the telephone box sanitizers, and the whole of civilization gets wiped out by a bug that starts in a telephone box. So, I mean, it's of its time in the 1980s, but that is exactly right. You know, you can't. It's very difficult to choose who you take.
Thanks, Richard. Sophie, one's come in for you. Patricia from Hitchin is wondering about double-yolked eggs. Since you brought in an emu egg, you can hopefully tell us all about this. She's wondering if you have an egg that has two yolks in it, will you get two chicks if they were to be fertilised?
No, unfortunately not. Well, actually, very happily for the chicks. So what's happening there? You usually get double yolked eggs from chickens when they are new to laying, and it's a mistake that they've made. So they've over provisioned an egg. They're often very small eggs as well that are coming from pullets. So when the chicken makes the egg, they're creating this yolk that's going to be it's full of fat and resources that's going to allow the developing embryo to grow. Now, it's a mistake that they've made because they're not used to that process yet, and they've overinvested in that egg. But when that egg is working its way down her tract, it will be fertilised by one sperm from the rooster. So you would not get two embryos.
So that there are not two fertilisable sort of precursors in there, in the same way as a human egg could actually split and make two, or you could have two human eggs and get two sperms and therefore have two non-identical twins. In that case, you can't do the same with a chicken egg. You can't split the embryo into two and end up with two developing chicken eggs in an egg.
I'm fairly sure you can't. I've never known this to happen in birds. However, in reptiles, these sort of mistakes do seem to happen. And this is why you seem to have a lot of very strange photos occurring of double-headed snakes, two-headed turtles. It seems to happen more often than would be predicted by chance. I mean, it is a chance event. So it seems to be that you can create twins in reptiles, but not in birds.
So there you go, Patricia. Your double yoker, eat with impunity. You're not killing 2 chickens, just eating 1 potential chicken. Thank you very much for that, Sophie. Kez, Georgie on the forum says, what do blind people see?
That is a very good question, and the short answer is it depends on the blind person, but probably more than you might imagine. Of the people in the UK who are registered blind, about 95% of them can see something, some level of light and dark. About 75% of people who are registered blind can read newspaper headlines. So most people have got some level of residual vision. And in fact, we no longer talk about people being registered blind, but we call it severely sight impaired these days because that's a lot more representative of what people actually see. But then what somebody actually sees kind of depends predominantly on the reason for their visual loss, and it can be quite different depending on different eye conditions. So if you take something like macular degeneration, which is the most common cause of visual loss in the UK, that damages vision in the centre. So in the middle of your vision, the area called the macula in the retina, which does the vision, which is the bit that you're looking at when you look directly at something.
So when I'm looking you in the eye,
so when you look
that's
straight
my
at
macula.
me, it's the macula that's doing the work there.
So if I had macular degeneration right now,
yeah.
I would look at you, but what I would see is the rest of the room at lower acuity because it's the rest of the room, but the bit where I would expect to see the most detail would be either blurry or, at worst case scenario, I'd just see a black patch.
Yeah,
no face.
You tend not to see a black patch. That's sort of that tends to be something that gets put in pictures as to this is what macular degeneration looks like. It tends not to be actually.
Just blurrier?
When you actually ask people, they'll say that things are kind of missing or blurred. The brain's brilliant at filling in. So if you have got this damaged area in the centre, mostly what will happen is that bit in the middle will be kind of filled in to sort of match the surrounding bit that is still working. And so with macular degeneration, people have still got peripheral vision. It's very, very rare that somebody would lose their vision altogether, but that central part of vision that you would use for recognising faces, for reading, that kind of thing, that would be the bit that was most impaired. But then on the counter side to that, you've got other conditions like retinitis pigmentosa, which is an inherited retinal disorder. So that affects the receptors at the back of the eye as well. But that predominantly affects peripheral vision. So that means that somebody with that kind of condition, tends to lose their peripheral vision but retain their central vision. So that's a little bit like looking through a tunnel. So you can see straight ahead, but everything off to the sides has disappeared. So that makes things like mobility and getting around, finding out where you are and how to get to somewhere, very difficult. But it still leaves somebody with enough central vision to maybe be able to read or use their phone. So there have been some instances recently where people have got into trouble, if you like, in that they're out and about with their white cane or their guide dog. Somebody spots them using a phone and goes, "Oh, you're cheating, you're not blind." But that's complete nonsense. You try living with only your central vision and no peripheral vision, and you will find that although, yes, you can use your phone, you are still very visually impaired by that.
Can imagine. Kez, thank you very much. Peter, let's delve into the quantum world now, because Sarah says quantum computing is now here. Well, perhaps you can comment on that. But she then goes on to say, but how far are we from having quantum computers that are on our desktops and also in our pockets?
Yes, okay. Well, quantum computing hit the headlines in the last week or so because Google came up with the new version, they called it Sycamore, which was 53 qubits. Very briefly and non-technically, a bit normally is 0 or 1. A qubit, a quantum bit, can have multiple states. So say it has 1,000, which is the number they're talking about. 2 together, there's 1,000,000, whereas 2 bits, digital bits, is only 4 states. It can be from that. So Google's created this thing which they claim will do a calculation that takes 200 seconds, which would normally take 10,000 years. So that's pretty quick. This, though, IBM then came back and said, look, we've got a quantum computer and we don't agree with this, and we think that you actually should be comparing 200 seconds with 2.5 days. Still a big difference. The point is what this quantum computer looks like. And there are some pictures on the internet. It runs at 15 thousandths of a degree above absolute zero. That's not going to be easy to get in your pocket for a start. So 15 millikelvins. There's also a few other problems. The qubit itself, if you've got a 0 or 1 in your hard disk or on your mobile phone, you want it to stay there. The decay time of a qubit is 10 microseconds, so it needs refreshing quite quickly. It also randomly will change state in a way that they don't really understand yet. So you need a lot of error correction. So they're saying that it'll take about 10 years before you get a big enough quantum computer in the lab to actually do something. And that's going to be running at basically absolute zero. It's going to take a lot of energy. So I have no clue how long it will be before it gets into our pockets.
Richard?
Well, I just had a question about this. Is there competition? You mentioned IBM and Google, because a lot of these things, I was talking about space and the space race, a lot of these things happen when you've got competition, people competing, and suddenly things get faster and faster.
Yeah, you can buy a quantum computer from a company in Canada, actually. I've forgotten the name now, but so you can buy it. It's only have a few bits long. The point is that it's sort of on the hype curve at the moment. It's going up there if everybody knows about the hype curve, the Gartner hype curve. And there's no doubt it will be of use. They say, for instance, that a quantum computer will be able to crack any cryptology in the world instantaneously. That means nothing is secret any longer anywhere. Now, of course, people are working on stopping that happening in all kinds of different ways. It's a very long way from any form of commercial use. But, yeah, competition does help.
Peter, thank you very much indeed. And if there's something that you've always wanted to know, then why not send in your questions to the next one of these shows and we'll try and sneak them in. It's chris@thenakedscientist.com or tweet @nakedscientists.
Hi Katie, how are you?
I'm pretty snug, to be honest. Quite cosy in here.
The Naked Neuroscience podcast explores the workings of the brain and the nervous system in our bodies and beyond.
It does not mean that you need to be sophisticated on the instrument. You can just hack on the piano.
Wow, so I can legitimately tell my friends to shut up because I've just passed my driving test.
You have my blessing, yeah.
Do you want to know who you are? Can we actually understand how we think?
From lifting the lid on consciousness to remembering how to forget, join me, Katie Haylor, each month as we make connections with scientists and spark up conversations on the latest neuroscience news. Listen and download for free at nakedscientist.com/neuroscience or subscribe to Naked Neuroscience wherever you get your podcasts.
Still to come, how much energy is the internet costing us and what might be the environmental consequences of that? Before that, though, here's the next part of our Guess Who game. Clue 1 was that this animal sounds like this. And clue 2 is these animals sleep a lot, about twice as much as us humans, and they live between 10 and 15 years on average. Is anyone any the wiser here yet? Any of you lot in the studio, any ideas?
Possibly.
Must be Sophie.
I wouldn't want to ruin it for the listeners.
You've got an idea. Okay, well, Sophie reckons she knows. Well, while you ponder further, Sophie, can you enlighten us? Neil EP on our forum is wondering about glowworms and says, how do glowworms glow? And how long does that go on for?
Okay, so glowworms are really interesting. They're actually a beetle, and we get them in the UK. And it's the female that does the glowing. So she doesn't typically transform. She doesn't transform in a typical way into an adult. So she looks a lot like a larva, but a heavily armoured sort of trilobite type creature, about 2.5 centimetres long. And she produces the glow. The male looks like a typical beetle, and he's attracted to her. So he'll fly through the night and be drawn in by her glow. Now, she produces a chemical called luciferin, which is fantastic, in reaction with oxygen that's produces with glow, so what we call bioluminescence, biologically produced light. Now, glowworms don't actually feed as an adult, so they metamorphose into their adult form and they don't have mouth parts. They do not need to eat at this point. All they need to do is find a mate and mate with one another. So she's kind of stuck. She's relying on reserves that she's built up as a larva. She's lived for about 2 years as a larva, actually eating, to make sure she's got enough reserves to produce this chemical reaction. Once she's mated, that's it. That's all she needed. So she will use her sperm, fertilise her eggs, and she will stop glowing. She doesn't need to anymore. She will hopefully find a mate. If not, she might run out of energy and she might have to stop glowing. But the males, back on the subject of eggs, they really like females that are glowing strongly because they're big. They contain lots of eggs, so he's going to get lots and lots of offspring.
And that's a sign, if they can afford to glow very brightly, they're well fed, lots of energy, probably a healthy female. Isn't it more likely to have healthy offspring?
Indeed, and also generally a bit larger. So what they call the lantern, which is the section of her abdomen that glows, will be bigger on a bigger female, and bigger female, bigger body, lots of eggs. So the males like that.
Thank you very much, Sophie. So there you go, shedding some light on how glowworms work. Richard, from glowing glowworms to rockets that go screeching through the sky, can you answer this one for us from Amalia?
What is the maximum speed for a rocket that is safe for a human to experience?
Okay, that's the wrong question. I'll come on to why it's the wrong question in a second. We're actually travelling very fast right now. So I had to write these down because I had to work some of these out as well, so they might not be wholly accurate. So the Earth rotates at 600 miles an hour. So we're currently on the Earth going at 600 miles an hour. Because we're on the Earth, we're also going at 600 miles an hour. The Earth is speeding around the Sun at 70,000 miles per hour. So we are also speeding around the Sun at 70,000 miles an hour. The Sun's speeding through the galaxy at 450,000 miles an hour, which means we're also spinning at 450,000 miles an hour. So actually we can go very, very fast. The proper question is, what acceleration can a human stand? So that's when you come into G-forces and the idea of the amount times gravity you can withstand. So typically a rocket, so something like the Soyuz rocket, which is what astronauts use to get to the International Space Station, doesn't actually accelerate that much. It's about 3 or 4G, if that, maximum going up to the space station. Coming back, it's pretty more unpleasant. It's kind of nearer 5G, but not for a very long period of time. So that's fine. We know from experiments done in the 1950s by Colonel John Stapp, a military doctor. He did experiments on himself, as all good doctors should do. He attached himself to a rocket-powered sled and sped along this track and then braked very sharply to see what G-forces, this is for pilots, what G-forces pilots could endure. The most he went up to, bursting all the blood vessels in his eyes in the process, but actually suffering no serious injury other than that, was 20 G.
Did he decelerate with his head towards the direction of travel or away? Because this makes a difference, because it makes a difference whether the blood goes away from your brain and you get blackout, or towards your brain and you get so-called readout. That's
interesting. So he was on a chair on a sled. I guess the acceleration would be going through his chest, through his body, the same way as astronauts. It's the reason they lie down on couches, so the forces are going through your body rather than straight down through your head, which is something you want to avoid. So yes, you get this idea of blackouts. And astronauts also wear, to avoid that, and pilots do, I mean, they have far greater G-forces, are pressure suits, and they will push the blood towards the head so you don't black out, because you don't want to be unconscious when you are flying a jet fighter.
So returning to the question then, which was, what's the best sort of rocket to go in terms of speed? Actually, that doesn't matter. It's the acceleration that matters, and the acceleration is what determines the G you're going to feel. And so what would be a comfortable G for a human to feel? I mean, when I'm taking off on an aeroplane, what sort of G-forces are those? Nothing.
Nothing really,
So that's what I want.
Yeah.
So basically...
Yeah, well, your best spacecraft, I mean, it's interesting because actually the best spacecraft for comfort was absolutely the space shuttle. Not too bad on the way up, and coming down, it sort of circled. It looped and looped and looped to lose energy as it came down to Earth. And as it did that, it was quite a gradual deceleration. Whereas the Soyuz, again, G-forces going up, not too bad. Coming back is pretty horrendous. I've heard it described as like going over Niagara Falls in a barrel, but a barrel that's on fire.
What a wonderful picture. Thanks very much, Richard.
The Naked Scientists podcast is produced in association with Spitfire, cost-effective voice, internet and IP engineering services for UK businesses. Find out how Spitfire can empower your company at spitfire.co.uk.
Music in the programme is sponsored by Epidemic Sound, perfect music for audio and video productions.
Don't forget, we have our Guess Who quiz running through the programme. I told you that our mystery thing sounds like this. That these things are fond of sleep. They spend about twice as long as we do asleep, and they live about 10 to 15 years. I can also now impart to you that an adult animal is a clowder, in a collective term. So in some ways we have a pride of lions, you have a clouder of these, and a group of the young of these are a kindle. So if you have any thoughts, let us know. I think this one's quite tough this week, but let us know. Now, a quick item to dip into the mailbox. This is the part of the programme where we relay your thoughts, comments and feedback to the programme. We heard from Ken, who said, "Hi, Chris. We heard the recycling-themed programme last week. Thought it was brilliant, and he really enjoys catching up with the programme as a podcast as well. So thank you very much for that, Ken." He goes on to say that I was bemoaning the fact that my lovely electric toothbrush has bitten the dust, not because it's failed, but the battery has, and there was no way for me to easily replace the battery, and I was moaning about engineered obsolescence in the part of my toothbrush and saying, wouldn't it be nice if there was a way to fix this and manufacturers had more responsibility? Well, he's given me a solution. He said there is an organisation which gives you instructions on how you can dismantle your toothbrush and bring it back to life. So I'm going to post you the details of this particular website, which is dedicated to replacing the batteries of electric toothbrushes at the end of the programme. So thank you very much for that, Ken. Now, every time we do one of these programmes, we have a little quiz. And this is where, rather than you sending in the questions, I've written some questions and you have the chance to enjoy them as well at home. But our panel will have their mettle tested. Now, our two teams are going to be Richard and Kez, they're team 1, and Peter and Sophie, you're going to be team 2. Now, round 1 is called Step Back in Time. So, team 1, which scientific invention that we all know and love was patented first? Was it the fridge or was it Edison's light bulb? What do you think, Richard and Kez?
Oh, I would say I would guess the fridge.
I'm thinking it's probably going to be a trick question because it feels like it ought to be the light bulb, so that might make it the fridge.
Yeah, because I would say, I think the fridge.
Yeah. But obviously not a fridge with a light in it.
Good. Yes, you wouldn't have a fridge. Yeah, very good.
Yeah, you get the ping for that. Indeed it is. According to livescience.com, Edison patented the first commercially successful light bulb in 1879, but the first fridge, which was a vapour compression refrigeration cycle that used liquid ammonia, was patented in 1835 by Jacob Perkins. OK, Peter, it's over to you and Sophie now. Which discovery came first, Volta's battery or Edward Jenner's smallpox vaccine? What do you reckon?
So, smallpox, when was that? 1830s? I
think so, yes.
Yeah, 1840s. And Voltaire's battery, that feels like it's older than that. But I think
it would be a guess from me.
Yes. What do you want to guess then?
Oh, crikey. Could we go for smallpox? That would be nice.
It'd be nicer if it was smallpox. You think it'd be a nice result?
It would be.
Well, I will defer to
Sophie. Are you going for the vaccine or are you going for the battery?
I think we're disagreeing here. So, shall we toss a coin? No, we give Sophie. Sophie went first. Yep.
Smallpox.
You're going vaccine. Yeah, well, good call. It's indeed the vaccine. Alessandro Volta, who is credited with inventing the first battery, he used zinc and silver in his battery, very expensive, gave a demonstration of his battery's generation of electric current in front of Napoleon in 1801, but it was in 1796 that Edward Jenner introduced the smallpox vaccine, from which the first commercialisable vaccines after that were invented. So there you go. Well done. It's 1-1, level pegging. OK, on to round 2. Round 2 is called Elementary. And we need you to tell us, Richard and Kaz, which of these radioactive elements isn't man-made. OK? Americium, curium, or plutonium. What do you think it is?
Plutonium. Oh, no, because you have to make plutonium, don't you?
Curium's got to be made by Curie.
Yes.
So I'm guessing not that one.
And americium, I think, was made... Yeah, I'm guessing in America.
It could be.
Yes, I would go for plutonium.
Yeah, let's go with that.
Oh, you're on fire. Americium and curium are produced by smashing neutrons into plutonium. You need a reactor to do that. Now, plutonium can be made artificially, but trace amounts of it do also occur naturally. So good call, well done to you. Right, Peter and Sophie, which one, also elementary speaking, which one of the following aren't elements that you would find in the periodic table? No cheating, by the way, no looking up the periodic table. Here are your 3 elements: didymium, dilithium, or dinitrogen.
So not in the periodic table.
Dilithium, that's from Star Trek. I hope that no one's found one and made it.
We're going dilithium?
Yes.
Dilithium.
I agree with that.
Actually, it's a pretty horrible question. Okay,
I'm sorry,
dilithium, you can make molecules of dilithium. You just take two lithium atoms and join them together, and that's commonly occurring. Dinitrogen, the same, N2, you just take two nitrogen atoms and they form a triple covalent bond. Didymium was on Mendeleev's periodic table in the early days. They used to think it was one element, but we now realise that, in fact, it's the combination of two rare earth metals, which is praseodymium and neodymium, and we can separate them apart. So didymium no longer exists in the modern periodic table. So I'm afraid it's 0 point for that one. Okay, so round 3, here we go. Now, this is pretty hard. We're going to see what you make of this. Okay, these are riddles, and you've got to solve this. So this round is called Solve This. Listen very carefully. You can take notes, Richard and Kez. You might need to, okay, but I'm going to be strict about the time because we don't have too long to answer this. You are on a forested island. It is 500 metres north to south and 3 kilometres east to west. It is surrounded by high cliffs and ocean. A wind blows constantly across the island from west to east at a constant speed. On Monday, at noon, the entire western edge of the island forest catches fire. Fanned by the wind, the flames are moving at 100 metres an hour across the island. If you're trapped by the fire, you're going to die. You can't jump off the island. With you is a rucksack which has got a penknife, a compass, a calculator, and there's a Bible in there for good measure. How do you survive until rescue arrives on Wednesday?
Oh, good grief.
Oh, no, I can't. You know, I was on University Challenge once, and I cannot process this sort of information quickly enough. You know, if you gave me a couple of days, I'd come back to you with a proper answer. Can we just run and jump in the sea or something?
No, we can't. We can't do that.
Okay.
How, if
Well,
we
while
go...
you're contemplating that, I'm going to come to the other team and I'm going to give you your one to think about too, because you can have some extra time to think then. So team 2, Sophie and Peter. A woman has a bucket of water in her hands. She turns it upside down, but the bucket stays full. There's no lid on the bucket and the water is in liquid form. She's not relying on centrifugal force. How does this happen? That's your question.
So it's obviously not frozen. There's no lid. She's not spinning it. Upside down. Is she in space?
Have you solved it yet, Richard and Kez? Do you reckon?
I think Kez has got a better
idea. So Kez, what do you reckon?
I think we've got to use if we head for the easternmost side of the island, the wind, the flames will catch up with us. So I'm wondering what will happen if we go to the northernmost or the southernmost point of the island. Will we escape the flames if they're just zooming across the middle of the island to the other side? But I suspect that's
it's a
not
good try.
right.
I'm afraid that you're not going to have that. Here's the answer, okay? You take a lit piece of wood from the fire that's currently burning. You hasten across to the other side of the island and come 100 yards inland and light another fire. You then retreat into the forest while it burns towards the edge of the island and burns out that bit of forest. Meanwhile, the other fire hasn't arrived yet. You then go into the burned out bit because you've created a fire break and you sit in there quite safely and eat your apple and read your Bible until rescue comes on Wednesday.
Very good, very good.
So I'm afraid that's... I liked your thinking, but that wasn't the right answer. Peter and Sophie, you got a chance. Did you solve it?
Well, we think it's a question that you didn't give to Richard because he might know it immediately.
You got to try me?
We think that
you're going to say she's in space.
Correct.
Yeah,
no, that's not the answer. No, she's not in space.
You're giving us another guess.
You could go on then. You can have one. Go on then.
Well, clearly it's not frozen. Upside down presumably means something. Rotating slowly is not going to work. It depends what upside down means, really, doesn't it?
It does.
Shall I put you out of your misery?
Yes,
I think it's going to be.
Sorry.
I think you're going to win for the first time, you guys. The answer is okay. She's underwater.
Oh.
That's quite cool, isn't it? That was pretty clever. Okay, so yes, the lady was underwater. So well done. This week's big brains of the week, Richard and Kez. Brilliant. Okay,
Half-hearted applause.
Yes, exactly.
Mark on our mystery sound. Mark's suggesting a cat, and Anita says, "Is that a cat noise as well?" Well, we'll find out in just a second, because I can also tell you that in the UK there's estimated to be more than 10 million of them. Anybody got any ideas what they might be?
I thought it was a sloth or something.
No, it's not a sloth.
Clearly not.
It's not a sloth. All right. Well, while you think about that one, Kez, here's a question for you. Roy wants to ask about blinking. He says, why do some people blink more than others?
Okay. Well, if we think first of all about why we blink, we want to spread the tears across the surface of the eye, and there's two main reasons for that. First of all, we want a nice smooth surface at the front of the eye, so that when light comes into the eye, we get a nice clear image that's sent to the back of the eye. If we think about, if you look through a normal window with a nice smooth surface, you can see through it, but if you look at a bathroom window, which is all bumpy, you can't see through it so well. So we want a nice smooth surface from the tears, but the tears also protect the eye to a certain extent, so they move little bits of debris and dust off the eye, and actually there's enzymes called lysozyme in the tears which have got antibacterial properties as well, so it's keeping the eye safe. Now there's three types of blinking. There's spontaneous blinking, which is what we do automatically without thinking about it. There's reflex blinking, which is what you do automatically when there's some sort of threat to your eyes, so you want to close your eyes to protect them. And then there's voluntary blinking, where you kind of think about it. So really the spontaneous blinking is the one that we're interested in here. And that's incredibly variable between people. So it's completely right in the question to ask why there is this variation. And there's a whole bunch of different factors. So to some extent, it depends on the quality of the tears. So your tears are actually made up of 3 layers, and the top layer is a fatty layer called lipid. And if you've got too much or too little lipid in your tear film, then your tears will evaporate quicker. And so you'll need to blink more often to get the tears to spread over the surface. And the same happens in different environments. So if it's very dry or very windy, again, the tears will evaporate very quickly, and so you need to blink more often. We also know that it varies with task. So if you're concentrating harder, your blink rate tends to go down. And you also blink less when you're looking at a computer screen compared to looking at paper, which is quite interesting.
What about lying? Because I heard that people may adjust their blink rate when they're telling porcupines.
There is some suggestion that when people are concentrating harder, and lying may take more concentration, that they might blink faster. And also if you're attracted to somebody, you might blink faster as well. So there's a whole range of factors. And in fact, normal blink rate can be anything from 4 to 20 times a minute. So it's really variable depending on the person.
Thanks for that, Kez. Now, Peter, can you help Louise out? Who's saying, we often hear it said that computers are getting twice as fast every year. But is this actually still the case? I haven't heard this for a little while.
No, this comes from Gordon Moore, who was one of the co-founders of Intel a long time ago. And that was true between the mid-60s and mid-70s, doubling every year. And then he changed it to doubling every second year up till about 2012, and it slowed down again. And we expect this to run out in about 2025, the speeding up, purely because we're running out of a space effectively on the chip. So it's going down to the 3 nanometer architecture moment, which is only 15 silicon atoms across. And so how do you create a transistor where you're getting down to the atomic level almost?
So basically the components on the chip are getting so small now that it's impossible really to shrink them practically any further than we already have.
Using the technology that's based on semiconductors, of course, we might be using other forms of technology, quantum computing, as we mentioned, or some sort of light processing. So, yeah, we're running out of that. But there's a bigger problem. Just to give you an example, though, I brought a computer in to show a couple of years ago here, which had 3,000 transistors on, which I built in 1975. There are 260 billion transistors in this phone in my hand at the moment. But again, this isn't the problem. It's not the speed of the processor that really matters, unless you've got a supercomputer, because the software sits on top of it. And the software is getting more and more bloated. And again, to give a little example here, I wrote some code back in the late 70s, and I spent nearly 6 weeks trying to remove 40 bytes, not kilobytes or megabytes or anything else, out of this code so it would fit in a particular chip size, which was 2 kilobytes long. So I spent 6 weeks. But nowadays, because memory, hard disks, everything is so plentiful, software is just getting bigger and bigger. And because of this, actually, the speeding up of the things isn't happening nearly as fast as the hardware is improving.
I have noticed, actually, that I haven't had to buy a new computer for a long time. And it hasn't actually deteriorated in performance terms. What I could have replaced it with wouldn't be that much better than the computer I'd had for the last 5 years, 10 years, whatever. And the thing that does shock me, as you say, is the software bloat. Because the first computer I ever owned was a BBC Model B microcomputer. It taught me to program, had 32K of random access memory. Not 32 gigs. You know, the idea of that sort of amount of memory.
Mine had 32 bytes, and I'm not that much older than you.
No, it's just amazing, isn't it, that the pace it's all moved on.
Yeah, so it's the software is the problem, not the actual hardware that's building it.
Thanks, Peter. Can you help Katie out with her bird question, please, Sophie?
My question is, where do birds go to sleep? I've never actually seen a group of them tucked up in a tree. And if they do, how do they not fall out when they nod off?
Okay, so birds, when they sleep, are very vulnerable. So they've got to find somewhere very nice and safe for them to spend the night, typically if they're a diurnal or, day active bird. They do tend to tuck themselves up in trees for the most part. And often they'll aggregate, so they'll join together in a big flock that will roost in a particular place overnight. And this is what we see in programmes such as Autumn Watch, with the big murmurations of starlings that are swooping around. They are in the process of finding a place to roost overnight. And that's typically in reed beds. So if you're in Cambridgeshire, you might go out to Wicken Fen in the evening and see these flocks, which that will then drop into the reeds. Another really nice example are pied wagtails, which we tend to see in ones and twos around the towns. But at night, they'll form big flocks and they'll roost together in safety, usually in trees that are in quite safe places, so supermarket car parks. There's a big roost at Addenbrooke's Hospital. And weirdly, where I am, when I grew up, where I went to school, there was a roost that happened at night. And I noticed this when I was a kid. I was there late one evening, maybe for a play or something, and noticed the trees were full of these pied wagtails. They all come together. Even like tree hollows, cavities, nest boxes that we put up to allow birds to build their nests and raise their young, they're a really nice, warm, safe place that birds can spend the night. They don't fall out of the tree because of the way that their foot muscles relax. So they're actually the opposite way around to how we would imagine. When bird muscles in their feet relax, they grip. So that's how they stay in the tree. They're relaxed, so they're holding on.
Do bats do something similar? Don't bats have an anatomical arrangement so that when the bat dangles upside down, as it applies force downwards on its claws, it actually encourages the foot to grip so they can hang upside down?
I believe it's the same mechanism, yeah.
Because the one disease that bats are really terrified of is diarrhea, isn't it, when they're in that situation?
Yeah.
But thank you for clearing up Katie's question, all the same,
No
Sophie, very kind. Now, Peter, can you help out Sam, who says, is there a plan to deal with the climate change impacts of tech stuff like server farms? What's he referring to?
He's referring to the very many data centres that are around the world, which apparently are about 7 million now. So in the way that one has a single computer somewhere, they've been put together in larger and larger groups. And this has been going on for many years. Once we moved away from the mainframe to the mini computer to effectively the PC, the PCs are then stacked up in large volumes, used by Facebook and Amazon and Google and Microsoft, etc. The sort of numbers involved, apparently about 2% of the global electricity usage is in server farms or data centres. That works out. There are only 10 countries that use more than this. So in fact, the UK is number 11. So it's between UK and France. So there's 2%. So clearly it's a large usage, and it's forecast to get up to 8% by 2030. And this is all the photographs we upload on social media, etc., and lots of other things.
Well, I did read a statistic from Cisco, who build a lot of the infrastructure that helps to run the internet, and they were suggesting that some enormous proportion, like 80% or 90% of the traffic, is video.
Yes,
internet.
Exactly. Yes, it's a huge amount. They're uploading YouTube videos, Netflix coming down, and all the other various TV streaming services.
Because, of course, not included in that power calculation, I presume, when you're just looking at how much pollution is attached to the internet, you're not looking at the end user. So you're working out what the data center to have the servers whirring away is, but you're not looking at all the people who've got their computer on, which is running at 300 or 400 watts of screen and base station and so on, in all those houses. So there's a much bigger footprint.
And, of course, our mobile phones, which need, even though they're not actually taking anything from the mains, they are doing when they're being charged up. And then these data centers, about half of what they use is for cooling. So effectively you're putting power in and it's obviously heating stuff up and it's got to cool it back down again. So what they're doing then is putting the data centers in places where they are cool, so above the Arctic Circle, etc. But the disadvantage of that, of course, is you've still got the heat generated. And where's the heat going to go? It's going to go into localized heating wherever it is, which means you can suddenly start growing palm trees up in the north of Norway or something, etc. So in the end, you've still got to remove that heat. And the thing that sort of is reduced that somewhat is more efficient processes. But of course, there's a huge more and more demand, and that's never going to catch up with that. I really don't know where this is going, whether you put them in outer space or something, but then you've got, how are you going to, you could power them solar power, but you've still got to get the data up and down to that.
I did suggest to a friend of mine who runs one of these companies that maybe he should relocate to a hospital, because the hospital I work in spends a fortune keeping the place very, very warm for the elderly people and people who are unwell in the hospital. And they're burning fossil fuels to do that. Hospitals often have big swimming pools that they'd like to dump heat into to warm up. They have lots of empty buildings they'd like to heat up to make sure they're nice and warm, and wards for things. And they have uninterruptible power supplies. What's not to like? I think it's just a space issue, but that might be one solution. Kez?
Yeah, and there are companies that produce a lot of heat in the processes that they use, that then use that heat to do things like growing indoor tomatoes. So you could double up in terms of getting rid of that heat and produce something tasty as well.
There you go. There's an idea to invest in, Peter. But thank you for clearing up that question for us. To make sure we don't forget to do it, I better put you out of your misery about this thing. Lots of people have actually, with the final clues, now got this right. Anna in Little Downham also right. It is a cat. Yes. So they sleep twice as much as humans do, or in the case of the cats I've got at home, about 5 times as much as I seem to. Yes, the young are referred to as a kindle when there's a group of them, and the collective term for a big group of them is a clouder. And there are 10 million pussycats in the UK. Just the UK. That's an eye-watering number of cats, isn't it? Kez, I want to sort of focus, if you'll excuse the pun, on this question, which came into our forum at nakedscientist.com/forum. It's from user Scientist. When you do a cataract procedure and you replace a fogged lens from a person's eye, normally that lens can have its shape changed subtly by the muscles inside the eye, which achieves a degree of tweaking of the focus. When one puts in a replacement lens to deal with the cataract, that can't change its focus, can it?
No, but there's other ways.
So how do I still see clearly then?
So the cataract affects the lens of the eye, which sits just behind your pupil. And the lens itself is you can imagine it a little bit like a grape. It's got a skin called capsule, and then it's full of the sort of the pulp of the grape, if you like, which are lens fibres. And the lens is a kind of an unusual thing in that it grows throughout life. You're continually producing new lens fibres at the edge of the lens and shoving the older fibres into the centre. Now, the lens is transparent because of the regular arrangement of those fibres, and we want it to be transparent so that it can let the light through to the back of the eye. But as time goes on and you increase the number of lens fibres in there, it pushes them all together, changes the regularity, and that can lead to clouding of the lens, which is a cataract. So, yeah, very common operation to remove that cataract. We peel away the little capsule at the front and essentially remove all of the contents of the lens with a little sort of surgical hoover type thing. Then you will put in an implant, a replacement plastic lens to replace the power of the eye. Now, the lens in anybody under 40 or so is able to change shape a little bit because this capsule on the outside of it is elastic. Your ability to do that does decline with time. That's why we all need reading glasses by a certain age. And that, again, is because the lens is becoming much stiffer because it's not able to change shape as there's so many fibres in that lens. So by the time most people have got cataract, they're not able to change the shape of their lens anymore. When the lens is removed, there's a little plastic implant that is inserted, kind of like a ship in a bottle, into the remaining capsule of the lens. In the majority of cases, that is a fixed focus lens, so it will be designed on the basis of measurements of the eye to give you a particular focal point. So either to be focused for distance, and then you'll need to put reading glasses on afterwards, or possibly to set you up for reading, and then you have to put distance glasses on.
Do you ever do one of each, so you can have a long one and a short one?
You can. So you can get around that. You can go for monovision like that. You can do that with contact lenses as well and give one eye distance and one eye reading.
And laser correction can do that as well.
You
can have one eye set for close work and one for longer.
You can do, and that does cover both bases. It does mess about with your binocular vision a little bit, so it might hamper your depth perception a bit. But the other thing that you can do with intraocular lenses, the implants that get put in, is you can have multifocal intraocular lenses. Not on the NHS, but you can have multifocal lenses, and they work by diffraction, so that the single piece of plastic produces two simultaneous focal points, one for distance and one for reading.
So does that get light going through it in different positions according to where you're looking then? So do you have to almost learn, like you do with bifocals, you have to almost learn to use them?
No, it's not quite like that where you've got sort of an area of the lens's distance and an area is reading. You have little circles engraved on the lens so that the light that falls in between the circles might be focused at one distance, say to give you distance vision, but the light that passes through the annular ridges on the lens will give you a different focal point to be focused for reading. So you get this sort of simultaneous two things in focus at once, but it can give you slightly less crisp vision. It can affect your ability to detect low contrasts. So it's not, because it's trying to do a number of things at once, it's not perfect at doing all of them.
So how is the fine focusing in a lens that can't change its shape achieved then? Is that purely by just moving your pupil wider and smaller in order to achieve a pinhole effect, so you can get that fine focusing and compensate that way as you get older? Is that what happens?
To some extent, yes. The older pupil is a little bit smaller, so you do get more of a depth of focus, because if you've got a smaller aperture, you get a wider depth of focus. But the short answer is that you will get your distance correction and then you will need a separate correction for reading. You can't have both at the same time.
So there'll be a sweet spot at which your vision works best, and then either side of that's a compromise?
Either side of that, yeah, but that's what specs are for.
Thank you very much for clearing that lens question for us, Kez. Thanks very much. Right, Richard, we've got this question, which James would like you to help him out with, please.
Is space tourism actually feasible and sustainable? Is it just for the super rich, or could it ever be a possibility for mortals?
It's just for the super rich. There we go. No, it's so currently a ticket on Virgin Galactic will set you back $250,000. It's a bit like what Peter was talking about, that it's in early stages. It's going to get cheaper. It's never going to be that cheap, but it might open the door to hypersonic travel from continent to continent. So, a trip from London to Sydney, say, in just a few hours. It might kickstart that sort of economy. There are a few rivals out there, but all of them are kind of around that $200,000 mark. I can't see it ever coming down a huge amount. But that said, I think there is one important reason why it's good that the rich and powerful can do this, because there's a lot of evidence that if you see the Earth from space, you get this idea of the Earth without borders. You can suddenly see the whole environment. And actually, if we start sending presidents and, the CEOs of companies up there, they might help to change the world.
About 2 or 3 months ago, we sent a helium balloon to the edge of space. We got to 33 kilometres and we played people's screams. Listeners to The Naked Scientists, we played their screams in space. But we also put 2 Huawei mobile phones in the box and took beautiful shots. We were joking, saying the people in Beijing had perhaps watched the footage before we got to see it. I'm sure that's not true. But we put these mobile phones in the box and we took the most gorgeous footage of the Earth from 33 kilometres up, and the blackness of space compared to this amazing iridescent blue. And it really does look like a marble. And honestly, I've watched that footage I don't know how many times, and it's awe-inspiring. So I know exactly where you're coming from.
It's what the astronauts talk about, this thin blue line separating us from the void, and it is just extraordinary. I think the more people that can see that and experience for real, it will make a substantial difference.
So if Mr. Branson phones up the Space Boffins podcast and says, Richard, would you like to go into space? What would you say?
I think I would have to say that, yes, I would love to go, but if to preserve my marriage, I would have to say my co-presenter, Sue Nelson, who's also my wife, she would so much love to go to space.
Well, she's been on the Vomit Comet, though, so she's got one. You haven't been on that.
No, I haven't.
So she owes you one.
I don't want to go into space. It's horrible.
And there we must leave it, I'm afraid. Thank you very much for listening, though, and thanks for sending in all the questions. Also, thank you to Richard Hollingham, Kez Latham, Peter Cowley and Sophie Moles, and to Katie Hayler, who put the programme together. Now, tune in next week when we're going to be delving into the science that is phenomics. Not sure what phenomics are? Well, this, I guarantee, is going to revolutionise the way that we do medicine in future. You can find out why next week. The Naked Scientist comes to you from Cambridge University and is supported by the EPSRC and Rolls-Royce. I'm Chris Smith. Thanks for listening, and until next time, goodbye.